Good afternoon, all. I specially welcome today's sixth session expert, Dr. Patil sir, in this 1 week online faculty development program on research methodology organized by PVPIT Budka. I also welcome all participants in this session. Now, I would like to introduce today's expert, Dr.S.D.Patil sir. He has completed his PhD in Mechanical Engineering from IIT Kharagpur. Currently, he is working as an associate professor in Mechanical Engineering Department of Rajaram Bapu Institute of Technology, Rajaram Nagar, Islampur. He has 20 years teaching experience. He is BOS member of Pimpri Chinchwad College of Engineering, Pune. He is DAP member of Vidya Pratishthan's College of Engineering, Baramati. He has also worked as a session chair for 10 national and international conferences. He has published 74 papers. Out of these, 22 papers are published in reputed journals like Elsewhere, Ville, 32 papers in international conference and 20 papers in national conference. He has filed 2 patents. Out of this, 1 patent on high traction manual tiller is granted. He has delivered 25 sessions as expert in various STTP conferences and workshops. He has completed some research projects also under first one is under Unnat Bharat Abhiyan project on semi-automatic chapati and papad making machine. Second one is the design and testing insulated turmeric cooker. Third one is the design and development of compact metal hydride reactor. Currently, he is handled a research project under Netra RIT project on thermal modeling and analysis of battery of electric vehicles. He is a reviewer of international journals, that is International Journal of Hydrogen Energy by Elsewhere, and second one is the International Journal of Thermal Engineering by Springer. He 21 MTech projects are completed under his guidance, and currently 6 PhD scholars are working under him. He's guiding them, and one PhD candidate is completed under his guidance. So today we will he will guide us on research design and planning, and we are very lucky about for his valuable time he is giving to us. Now I request Dr. S.D. Patil sir to start his session.
Hello, may I audible?
Yes sir, yes sir,
The screen is visible.
yes sir.
The PPT is in presentation mode or
No sir, presentation not in.
now?
No sir.
Just check.
Yes sir.
Now it is the in presentation mode.
No sir.
Just a minute.
Yes sir.
Now it is in.
Yes sir. Yes sir.
Okay, shall I start?
Yes sir.
Okay. So thank you, organizing committee members, as well as the head of the department, mechanical engineering, for giving us opportunity to deliver the session on this topic, that is research design and planning, in this online workshop or FDP on research methodology. So yesterday you have one session on the same topic content, that is research design and planning. So in addition to this, I am also going to add some values to this content, that is research design and planning, the key concepts and methodology. So as rightly mentioned by the land madam. So this is my brief publications. Just I have total 74 publications, and out of which the international journals are 22, and remaining are in the conferences, as well as two patents. I have one granted and one filed. So these are the some of the major publication, because all of you are from mechanical engineering, and this is one of the reputed journal published by elsewhere. It is a international journal of hydrogen energy, in which my major work is published there. So these are the some of the screenshots. Just I would like to show to the participants. So this is about the my major work is it related to the metal hydride reactors and nanofluids, and second is about the battery thermal management. So this one is about the metal hydride reactor performance analysis with the material as a sodium alanate. This one is the also makes paper, that is enhancement of heat and mass transfer characteristics of metal hydride reactor used for hydrogen storage using nanofluids. Then this one is the basic fundamental paper, that is analysis of metal hydride reactor for hydrogen storage. And related to the entropy generation, we also worked, and we have published a good paper in the journal. So in addition to this, also the papers are published in other journals that I have not mentioned over here, as madam told you. So with this brief history of the publication, we will turn towards the content of the today's topic. So I would like to cover the, in short, whatever the research design is there, elements of the research design, then types of research design. These parts yesterday you have covered, so I will just have a one recap of all these in short time, and then we will move towards the from design to operational planning. Then what is the research questions, research sub questions, hypothesis. Then I have taken case studies 1, 2, 3, about which how the research questions are there, sub questions are there, hypotheses are there related to my topics, whatever we have uh, just published. Then the planning matrix of research, planning, research planning process, then the different data collection methods, what are the ethics in research, how the timelines are there, then what are the different challenges and their solutions. And lastly, also, whenever you are going to complete your research, then the very big question that will be asked to you as what is your contribution as a researcher to the society. So, how the research contribution can be written from your research work? That one of the sample copy of my work I have written over there, and then we'll have the question answer sessions. So, short introduction about this again: research design. So everyone is well popular with the design words, and it is related to now research design. So research design is nothing but it is a systematic plan or systematic approach to collect the data and analyze it, whatever the research you want to do it, and you have to collect that information and present it. Okay, so research design is nothing but it is detailed plan or a strategy that specifies the methods and procedures for what the collecting and analyzing the required information. Okay, so it is essentially a framework. It is essentially a framework where we are going to answer the different questions, and also we are going to test whatever the questions we have asked during the design of this research. Okay, so why we require to have a research design? So there are some important points that to be noted over here. If you don't have any research design and then planning, then your research work will be scattered over. It will not be channelized and it will not be completed within the stipulated time periods. So everyone as a researcher, whenever you would like to enroll for the research and try to complete this research within the stipulated time period, then you require to have some design and planning. Design and planning. So what are the importance of research design? So first one, it guides the research process. So firstly, it is nothing but what it is a blueprint that outline the entire research process. So whatever your research work is there, that is to be outlined as in steps, and it will be a work as a blueprint for you. So what is my first step? What is my second step, third step, fourth step, like that, and how I can approach towards the final end. in order to complete my research work. So it will give complete guide for the research process. So when you are going to have research design, then also it ensures validity and reliability. So one thing is that whenever you are going to do the research, the validity is very important, because which what principle or what fundamentals you are going to proceed ahead your research, that is to be required validated. So it helps in obtaining valid and reliable results and minimizing the bias and errors. So minimizing bias and errors means what? You have some research and you have some findings from that research. Then it should be justified or interpreted properly. And whatever the error is there between the fundamental or between the model with which you are comparing, and that error, you should have minimum error and there should be minimum bias between these two. And that you require to interpret with the results. So when you are going to have the research designed properly, then you can ensure this validity of the whatever the results are there, then the reliability of the results, that accuracy of the results, and you can confidently say that these are the outcomes of my results. Then also you can have the facilities of resource management. Now you have decided something research to be done in the some areas whatever you have chosen, then you should be able to know that what are the resources required. So in terms of the resources of the, suppose, what is the efficient allocation of the time, what are the efforts required, and that resources which are available with you is made possible to well thought research design process. So you can manage these resources in a such a way that you can fulfill the whatever the objectives of the research work you have decided. Then also this research design will enhance the understanding. So it helps in clearly defining the research objectives, scope, limitations, and making the research easier to understand and interpret. So if you are not having the research design and planning, then you will not be in a position to say that what are the my correct objectives, what is the scope of the objective, where I should stop, where I should go in depth, where I should have, or what are the constraints, limitations for my research work, and it will make easier for you as a researcher to understand and interpret the what are the objectives you are going to have. Okay. So for this purpose, you require to have research design and planning. So these are the just points which you have covered yesterday, that are the different elements of the research design. So whenever you want to have any research design, firstly you should have a statement of the problem. So what is exactly problem? What gave rise to this research? Okay, so anything, as yesterday you have seen the different types of research. It is a core research is there, applied research is there, then you can have any laboratory research is there, or field research is there. Like that, different types of research are there, and in that you are going to define the problem. So statement of the problem is very important. If the statement is not clear, it is not clearly understood, then the research design will be it will not be planned clearly. So to get this, you require to have exhaustive literature. You, so sometimes people may say that this is my very new topic and I don't have any literature related to this. Like that terms are there, but that is not case. Nothing or no topic will be without any literature. There will be some inclination of the topic with the literature, and you require to connect this literature with your whatever the topic or problem you are going to present or you are going to select. So you have to get the exhaustive literature you for the whatever the research design you want for your research topic, and you have to include it in the research design. And probability that you have to go for the current literature, that is right now suppose it is 24 is going on, so you can have last 2 to 3 years papers from various publishers. So Elsewhere is there, Springer is there, Emerald is there, then ASM is there, or you can have John Valley publications are there. So these are some of the standard publications are there. From these publications, you have to download the different papers related to your work and have exhaustive literature review, and then you can connect it with the what are the problems we have selected for your research design. So there are different constraints on the research that also you have to take into account, that to manage the time, manage the people, then the if any their politics involved is there, So if your research is related to, suppose, the any strategic plan related to the public domains are there, then there will be some politics will be also there. Then the access to the whatever the resources are there, like that. So you have to also define the constraints, and you have to work out on that constraint, and as per that constraint you have to write the objectives so that your objectives will be completed in the stipulated time periods. If you are not taken into account the constraints and you are liberally going on writing the objectives of your research, then automatically, with the time of 1 year, 2 year span, your research work will be stuck and you will not come out of that. And you may get some kind of, I may say that, disappointment about the work, and your work may get prolonged. So before going to this, you have to define the constraints. So what are the constraints on the research? Then you have to have aims, purpose. Then what are the outcomes you are getting, intended outcomes from this. Then next steps, what are the nature of the phenomenon now to be investigated. So this is also important, that the what you are going to investigate from your research.
ಅವ್ರು ಅಲಾಟ್ ಮಾಡಿದ್ರೆ ನಾವು ಮಾಡ್ತೀವಿ ಸರ್ ಅದಕ್ಕೆ.
Hello. Okay. Nature of the phenomena of investigated, that is also required to be taken into account. That is, you are investigating these research outcomes in terms of experimental work, in terms of numerical work, in terms of the simulation, or in terms of field survey results, or in terms of the, you can have questionnaires, like that, and what methods you are using to collect the data, and then you are going to investigate in that in details. Then the operationalizing the research aims and purpose. So you have to do it in detail, the operations of the whatever the steps you are going to have towards the planning. Then most importance are there, and I'm going to focus on this. The research questions, that whenever you are going to find any problem, research statement problem, then you have to have the research questions on that, and how to formulate are these research questions, and how to focus on this research, that I'm going to focus in these coming slides. Then the priorities for the research, that is very simple step, that how you are going to prioritize your research work with whatever the regular works you are going to have, and with that you are going to proceed ahead. Methodologies and kind of research, what methods you are going to use for this. Next to that elements are also, that is nowadays coming ahead, these ethical issues. That is in terms of plagiarism is there, in terms of the copy of the material is there, use of the different tools, that whatever you are going to use. Then any research document, whenever you are citing there, then you have to properly cite it, like that. Whatever the ethical issues are there, that should be also taken into account. Then the ownership of the research and data. So if you are going to take the help of anybody else which is assigned to you to help you for the research work, like that, then you have to clearly define that this, who is the owner of this data, or who is the owner of this research. Sometimes every paper nowadays, research papers, whenever you are uploading and trying to publish it, the conflict of interest is taken, and as well as the your recommendation for the ownership of the work which is done in that paper is also asked nowadays. Earlier days it was not asked, but nowadays people, these publishers are asking contribution of each and every author which are mentioned in that research paper. So automatically you will give the contribution in terms of the ownership of that, whatever the work you have done in that research. Then also it is important that where your research is going to be published, who are the audience of your research, what are the different instruments which are used, then what is the sampling size. So whether it is a pilot sampling or whether it is a strategic stratified sampling, like that. Time frames, then what sequence you are going to use, what are the resources required to collect the data or material. Then as I mentioned, reliability and validity of the data which is used. Then once you have decided your objectives, you have started working on that, then automatically the collection of data will start. So suppose you have done the numerical simulation, numerical model, or experimental work. So you have already fabricated the model and installed it, fabricated it, installed it, and tested. So automatically with different operating and design conditions, your data will start generating, and you are trying to get it with the data acquisition system or by simulating this with the computers and all this. So you require to verify this data and validate this data. That is very important. You require to look that whatever the data which is generated is as per the fundamental laws or not. Means what? Suppose we are adding some additives to improve the thermoconductivity, and when you are going to take the readings, and then you are not going to find major difference in the change in the heat transfer or change in the conductivity whenever you are adding something like that, then definitely there is some error, or definitely whatever the procedure you adopted for doing these experiments will, they might have some errors, and because of which the data which is generated is not valid, or you require to verify it. Okay, that is very important. Otherwise, day together, hours together, if you work out and have collection of data, and at the end you are trying to look into the data and you come to know that the data which is collected is not valid or not verified correctly, then the whole work last 1 month, 6 months or 6 days, whatever you work, that will be lost. So that care you require to take during the research, designing, data analysis also, and at the end you are going to have the report writing for the research, and the publications are there. Okay. So this yesterday this part also covered. That is the major. There are different types of research designs are there: exploratory research, descriptive research, and explanatory research. Okay. So this part I will not take in much details. So as you know that exploratory research means to explore a problem or situation. Descriptive means what you have to describe the characteristics of the population or something like that. And people are going to use the methods as surveys, observations, case studies, and they are going to describe the conditions, characteristics of the whatever the system is there. And explanatory research is nothing but to explain the relationship and causalities between the whatever the research questions you have, and whatever the problem you are going to have. So you are going to use the methods as experimental methods, then the longitudinal studies like that, and you are going to examine the relationship between these two. So most of the times people are going to use this academic research with this experimental type research methods. Now with concern to earlier slides, then what kind of research methods or types you are going to use with respect to what are the purpose of your research is there. So I make the two columns over here, the kind of research purpose and kind of research that you are going to have. Okay. So suppose if we take first question, that does the research want to test a hypothesis or theory? Okay. So in your research, you want to test the hypothesis or theory, then what kind of research types you are going to use and methods? Then you are going to have the experimental method, survey method, action research method, case studies like that. So by using these tools, you can do the research, and you can test the hypothesis of your research. Does the research want to develop a theory? Suppose you want to develop a theory, then you can have qualitative research, grounded theory, okay, or ethnographic surveys or theories are there that you have to use it. Then does the research need to measure? In the research you would like to have a measurement of something, that how much it is improved, how much change in the values are there. Then you have to conduct the surveys or experiments. Then you can say that earlier this value was there and now this value is there. Okay, so there is a measurement and comparison is there. So you would like to have a performance of the engine with some alternative fuels and like this. And you can say that with the petrol or petrol, the earlier efficiency was 25, now with the some alternative fuel it is now 28%. So there will be measurement, so you are automatically have a experiment on that and measuring these values. Next is, does the research want to understand a situation? Then you can use the qualitative approaches, interpretive approaches like that. Then you can have next question, that does the research want to see what happens if? So it is one kind of, one can say the trial and error types researches are there. You can use this one, you can go for this one like that with some hypothesis. Then people are going to use the methods as experimental methods or participatory research or action research, and then they are going to analyze what are the outcomes of that, whatever the addition you have done or applications you have changed from that research. Next, that does the research wants to find out what and why? Then the people are going to use the mixed research methods. So qualitative or quantitative methods are there. In that you can have a mixed research method. So people are going to opt it. And lastly, that the research wants to find out the what happened in the past. Then it is historical research is there. So that is mostly the other not in non-engineering peoples are going to use the what is happened in the past. So historical research are used. So these are the different types of research methods, research design types are there, and these are the different tools people are going to use to achieve their research. Now you have the research design with you, and you are now going to plan it to complete. Okay, so from design to operational planning, you have defined the different stages. You have framework is created, the different steps that you would like to approach 1, 2, 3, 4 like that to the end of the research. Now there is a need to plan it. So design and planning is there. So from design to operational planning, you require to move ahead. And here also, these are the some of the questions you require to take into account while going for the operational planning. So what is the method you are going to use? So does the research need mixed method? So as I mentioned that you have qualitative, quantitative methods are there and mixed methods are also there. So your research, whatever you are designed, is required any mixed method. Then if so, is the mixed method research is parallel, sequential, combined or hierarchical approach? Like that, in that again in details you have to go and decide that plan. So whether I should go for parallel analysis, whether I should go for sequential analysis, whether I should go combined analysis like that, or whether I should go hierarchically approach. So one by one with higher orders, I can go ahead with the whatever the steps we have written. Then, what are mixed methods research questions formatted where appropriate? So, whatever the mixed methods you have opted for your research questions, that you have to decide whether it is appropriate or not. If it is not so, then again come back and change the research question and then change the method. Sorry, not question, change the method of whatever the research design is there, and then again go ahead with the whatever research questions you are having. Then you have to also decide that whatever the data which is generating from your research, how you are going to validate it. So how will validity and reliability to be addressed? So where we are going to compare this data, that you have to plan it, that I have generated this data for my research question and for my research design, and now I require to validate that data. So how will validity and reliability will be addressed, that also planned. Then what kind of data are required? So you require experimental data, you require numerical data, you require survey data or questionnaire data, that you have to decide during the planning, and according to that you have to plan it. If survey is there, then you have to have a questionnaire, then you have to visit to the various industries, or whatever the field of work is there, then you have to give questionnaire over there. Nowadays people are going to give it online through emails or through various platforms, and then they are going to collect the data like that. So what kind of data are required for your analysis? So that also you have to think during the planning. Then from whom will data be acquired? That is in terms of sampling size. So it is a batch sampling, stratified sampling, group sampling like that. Or you can have a region, that is region in the Western Maharashtra, or region in the boundaries of the Western Maharashtra. Like that, you have to decide it, and you have to take the sampling from that, and then you have to go ahead. So if you would like to analyze that effect of Industry 4.0 on the boundaries in the Western Maharashtra like that, and in that you are going to take the research questions and this, then you have to just have a sampling, and you have to take minimum sample data and all this and have the analysis of that like that. Now where else will be the data available? So it is a documentary data is there, then the what is, whether it is authentic, whether it is you can say that approved, or whether permission is taken to get the data from that whatever the resource is there. Okay, that kind of things also you require to plan during the collection of the data. How will the data be gathered? So what is the method, instruments that you are going to use to collect the data? That also you require to take into account. And who will undertake this research? The very correct question is there. Now, who is doing this research? Who will undertake this research? So during this research design to planning, so firstly you have to design it, and then you have to plan it to execute this design. And it is a strategic plan is there. It is a framework is there, and step by step, as per your problem statement, you are going to have the research questions, sub questions, hypothesis, and then you are going to have the objectives with the objectives 1, 2, 3, 4 like that, phase 1, phase 2, phase 3 like that, and at the end getting the gathering the data, analysis of the data, and then comparison of the data with the whatever the published data may be there, or any whatever the available data with you for the validity and the reliability of the data, and then you will get the good publications from this whatever the research you are going to have. So these are the some steps just I have narrated over here, which you might have come across yesterday in the same lecture of research design and planning. Okay. Now, next one is the matrix of research design. So now it is very important that you have research design, okay, and also planning is there. So for this research design and planning, as I mentioned that you have first step, that is the problem statement you have decided clearly, and with the problem statement we have, before that also I may say that you have exhaustive literature survey. Initially you have broad problem, then the exhaustive literature survey, then you have identified a gap. With the gap you have defined a problem statement. Now based on the problem statement, next steps, that is the very important step in the matrix of research designs, are research questions, then you can have sub questions, and then you can have hypothesis. This is very important. So you have to raise the questions on your problems. What are the research questions you are going to have? Then again in that bitwise sub questions 1, 2 you can have, and on which hypothesis it is going to work. It is going to work. Okay. So hypothesis is very important for this, because you are not going to do much of us or all of us. I may say that broadly, it is not a blue sky research, but it is one kind of applied researchers are happening, and with some theories, fundamentals or principles, we are moving ahead with the research. All right. So here these are the research questions, sub questions, and hypothesis that we are going to see. So what is this research questions? The research questions are nothing but these are specific queries the research seeks to answer. So as a researchers, you are going to have queries about your research, and you are going to ask the questions. Okay, and we are expecting some answers for these questions. So these research questions are the specific queries the researcher seeks to get the answers from this. And then sub questions are nothing but again it may be the broad question, and it may consist of the some sub questions in that. Then you can have sub questions on that also, and then you have to see that hypothesis of your research. So hypotheses are the testable statements. These are the statements, and that should be the clear statement, clearly understandable statement must be there. So these are the testable statements predicting the relationship between the variables. So whatever the variables you are going to decide in your research work, that is the, suppose I may say the variable as a conductivity is there, pressure is there, temperatures are there like that, and I am going to say that because of the change in conductivity of the material, there is improvement in the heat transfer like that. So this is the what hypothesis is there, and as you know that the conductivity is more definitely as per the law. We are having, suppose as per the Fourier's law, Q is equal to minus K dt by dx, or as per the Newton's law, Q is equal to HA delta T is. So if the H heat transfer coefficient is improved, definitely heat transfer will improve, or minus K dt by dx, K is improved, there will be improvement in the heat transfer like that. So here we are going to have a relationship between the different variables. So I may say that if I want to improve the heat transfer by the Fourier's law minus K dt by dx, so I can change the K, I can change the delta T, so that definitely there will be some improvement in the heat transfer. Okay, so this kind of hypothesis I have in my mind, And definitely, I may say that in my research, if I change this parameter, this variable, by addition, by how some work on that, it may be any operational change, it may be in the property change, it may be in the design change, like that, and definitely I will get some good results. That is the, so my research questions will be related that does by adding something in that base material, can I get the improvement in the heat transfer, like that I have questions. Okay, so these hypotheses are nothing but testable statements are there that are going to predict the relationship between the different variables. So this hypothesis also guides the research process, helping to focus the study and determine the methods that to be used to complete this research. So up to this, it is clear. Anyone is having doubt or any queries? Now I am going to tell the different case studies related to the research questions, research design, sub questions and hypotheses related to our work which we have carried out in last few years. Madam, is it audible?
Yes, sir. Yes, sir.
Okay. So we'll have question answer at the end. Or so up to
Yes, sir.
this, I hope that this content is covered a lot in the earlier lectures also. Now I would like to focus that how to frame the research questions, sub questions, and hypotheses. Because with these research questions and hypotheses, your research work is progressing. If the hypothesis of the research is not clearly understood, then your research may not be, I may say that approached within the stipulated time period towards the completion. So it may get scattered, it may be directionless, like that. And with this, I am going to focus now on the how to frame the research questions and hypothesis. Okay. Now the case study one is there, and it is my array is there. That is the, it is about the hydrogen storage is there. Okay. Nowadays, everyone knows that the conventional vehicles are going to be replaced with the electric vehicles, as well as nowadays the green technology or green hydrogen, that concept is coming, and there is a possibility of the coming few years the engine may be fueled with the hydrogen. And one of the major issue with the right now hydrogen, the storage of the hydrogen is there. So here I have shown the picture of the vehicle, and now you know that there are different methods of storage of the hydrogen. Okay, so just I'm telling the background about getting this detailed statement. So here I would like to store the volume of 4 kg of hydrogen, and then I have different methods to store it. So you can see here, this is the, towards the right side, the big barrel type cylinder is shown, where I shown that it is the hydrogen which is stored in the gaseous form, which is at the 200 bar. So this much volume is required. If I would like to store it in the liquid form at the low temperatures, same 4 kg, then this much volume is required. If I would like to store it in the intermetallic bonds, that is the metal hydrides, these are the nothing but metal plus hydrogen reaction is happening. It is endothermic and exothermic reactions are there. Whenever you would like to store the hydrogen, you have to supply the hydrogen and it will react with the metals and form the bonds. And then whenever you would like to release it, they have to supply the heat externally, then it will come out. Like that principle is there for the metal hydride storage. So this is the one of the metal hydride tank LaNi5S6, where to store the same volume of 4 kg, this much volume is required. If you would like to have another hydride, that is Mg2NiH4, then again this much volume is required. Now you can see that if you store the hydrogen in these different methods, liquid, then the gaseous form, and in the solid form, then the volume required will be different. Okay, so currently the storage of hydrogen is one of the issue, and we have obtained that how to store the hydrogen in this solid form, that is metal hydridic forms. And we have chosen the topic that there is a lot of scope to have the reaction kinetics between the storage of hydrogen and also release of the hydrogen in the hydrides. So here, instead of the liquid form, which is required to be stored at very low temperature, instead of gaseous form, which is required to be stored at very high pressures, and carrying these high pressure cylinders in the vehicles is nothing but it is very dangerous to carry it. So that these two options are not opted by peoples. So people thought that can we have these hydride forms, and which will be have cylinders or have a cake type tubes which will be fitted in the vehicles, and with some external heat one can take out the hydrogen out of it. Okay, so this is the hydrogen storage. Three types are there. For three types are there, and you can get it easily. That with the liquid and gaseous form, you can get the lower volume with the solid form for the same 4 kg of hydrogen. So here the case study is that I would like to analyze the heat and mass transfer studies under tubular metal heated reactors. Suppose so here, for understanding purpose of research question, I will just again explanation of the how the reaction is happening. So initially, you are going to have the source of hydrogen tank, and from that, I am going to take the hydrogen, and this is the reactor where it is storing the hydrogen in the hydride forms. So in this cross section, you can see at the center we are getting hydrogen, and in the hatched lines we are having the hydride, and black color is the thickness of the reactor wall is there, and around this again concentric tube you are going to have the coolant. It may be initially for the extracting the heat to absorb it, store it, and when you want to take it out, withdrawal or release of the hydrogen, then you have to supply the oppositely hot fluid. So here you can see the blue dotted lines are showing the charging, that is the absorption of hydrogen. Red dotted lines are showing the desorption of the hydrogen, and that is the take out hydrogen at a different pressures, like this. So through the exhaustive literature survey, we come across that there is a lot of scope in the heat and mass transfer analysis studies, because if the reaction is happening faster in the reactor, the rate of hydrogen absorption will be faster. It is nothing but one kind of refueling is there. Likewise, when we are going to visit our petrol fuel station, diesel fuel station, and when you like to refill the petrol or diesel in your vehicle, how much time you can spend? जर आपण पेट्रोल पंपावरती गेलो गाडीमध्ये तेल टाकण्यासाठी, तर मॅक्झिमम वन कॅन स्पेंड 10 minutes. So within 5 minutes one can have the refilling of the 10 liters, 20 liters, like that. Okay, so likewise same system here, it is to be proposed that whenever you would like to charge with hydrogen, I can spend maximum 5 to 10 minutes. So we have the heat transfer analysis such that this hydrogen can be stored in this reactor within the 5 minutes. So it is about 600 seconds or 300 seconds, like that. You can have 5 minutes to 10 minutes time is there, like that. Okay, so people have proposed a lot of things. So these are the various geometries which are published by the different authors. So Mowley et al, they have proposed this kind of reactors where you can have helical coil, then black color shows the hydride, and this is helical coil shows the insertion of the coolant. Or you can have here, you can see the inner duct is there where hydrogen is supplied and the coolant is also circulating around it. He proposed these many reactor designs. Another author also proposed this design, that is you can have the inner tube with the circumferential fin tube heat exchangers, and inside this tank inner volume you can have hydride, like this. And here these are the, here at the center you can have water in and out is there, so that heat. So because of this, during absorption heat is evolved, you require to extract that heat fastly so that hydrogen will be absorbed fastly. That is the principle. So to require less time, you require to extract the heat fastly. If you are not extracting heat fastly, the time required for the absorption will be lower. Okay, so this fundamental is there for this first case study. And now on this, the research questions are designed and the hypothesis is designed. Okay, so what is the first research questions for my research work? So you can see here, can a structured theoretical formulation to be developed for optimizing metal hydride systems which is suitable for hydrogen storage and other applications? Okay, so can we have a metal hydride system which can be used for the hydrogen storage as well as any other applications also? Okay, that is my question is there. Then sub question I can have, that is, how can introduction of second law analysis help in building the aforementioned formulation? Because through the exhaustive literature I come to know that many of, as I have shown earlier also, so these are the some designs, these are the some of the sample designs just I have shown. Lot many designs are proposed by the many authors, and have good publications in the International Journal of Hydrogen Energies. Okay, so with this, they have formulated the first law efficiency. Now, can we have the second law analysis efficiency related to the entropy? And then we can get the insight, clear idea about that, the how one can introduce the second law in helping to help in building the optimized metal hydride systems, which can be suitable for storage of hydrogen or any other applications. Okay, so based on these two research question and sub questions, I have the research hypothesis. How? So application of second law along with heat and mass transfer models, materialized system can be evaluated to propose suitable functional designs that can work under different conditions and applications. Okay, so this is the research hypothesis. So what I can say that because of the application of the second law of thermodynamics, okay, along with the heat and mass transfer models, the metal systems can be evaluated to propose suitable functional designs which can work under the different conditions and applications. That hypothesis. So here I know that if I implement the second law to this system, automatically I will get some optimized metal hydride system reactors, because earlier to this many researchers have worked on the first law analysis and they tried to give the time record for the different absorption desorption times, and with respect to that they have published the data and all this, but they have not done the second law analysis. So I come back to know that one can use the second law for this and have analysis for that. Based on this also second research question on the same, is it possible to develop a structured methodology using which the commercial viability of metal hydride based water pumps can be evaluated? That is, it is related to the applications of the metal hydride reactors other than the engine, as I said, as a fuel. So one can use this metal hydride also for the different systems, the pumping water, then have a refrigeration system, heating system like that, or have a compressor systems like that. Also applications are there. One can go in detail. If you click only metal hydride in the Science Direct reactors, you will get thousands of publications through the International Journal of Hydrogen Energy journal. So here the question is defined that is it possible to develop a structured methodology using which the commercial viability of metal hydride based water pumps can be evaluated. So I have taken the water pumping as application for the metal hydride reaction. How can we develop such model? So how can introduction of economic analysis help in achieving the above? Second question is that I propose this model, but is it that model economically viable with the existing systems in the society? That is, I have solar water pumping system, I have any biomass water pumping system, I have any diesel pumping system like that. In comparison with this, if I propose the metal based water pumping system, then is it economically viable? So that my research question is there. How can introduction of economic analysis help in achieving the above pumping system? So my hypothesis is that applying a proper economic analysis methodology along with the suitable thermodynamic and heat transfer models, okay, in order to compare the economics, I have to do thermodynamic analysis, heat transfer analysis of that model, and then check the commercial viability of this metal-based pumping systems. So this is the research hypothesis, and with that hypothesis, I proceed ahead and I have decided the objectives of my work. So these are the objectives based on this work. Okay. So how the objectives are decided? That is to develop a simple but sufficient accurate heat and mass transfer model of a metal hydride reactor suitable for a variety of applications. Sorry, because here I am going to make the heat transfer model for the generalized application, not a particular application. So it can be used for a variety of applications. So using this model to predict the thermodynamic and heat transfer performance of a low temperature metal hydrides, including entropy calculations in the heat and mass transfer models. So what I proposed, I will have the thermodynamic analysis, I will have a heat transfer analysis, as well as I will have a second law analysis, which is going to relate it to with entropy, which is not done earlier by any researcher. Next objective, that is to analyze the heat transfer performance of a large metal hydride reactors using a high temperature metal hydrides. Earlier, this second objective is for low temperatures. Next objective is for high temperature metal hydrides. Then next one is to conduct the feasibility studies of metal hydride based hydrogen storage system for biohydrogens. That also from the bioorganics we can generate the hydrogen. So can we able to capture it and store it? That proposal also made in this. And then compare the thermodynamic transfer and economic analysis of this renewable energy driven metal pumping system for the rural applications. So I would compare this thermodynamic model, heat transfer model, and economic analysis model with application as a water pumping for the rural applications with the existing models which are available in the market. Okay, so based on these research questions and the starting with this hydrogen storage, and I have moved ahead with the exhaustive literature, then I have understood clearly the what are the fundamental working principle of that system is there, what are the different proposals, what are the different researchers done by the various researchers in the reactors. Then I have framed the research questions, sub questions, hypotheses for my research work, and based on that I have decided the objectives of my work. Okay, and now with these objectives I will move ahead with detailed planning to execute these objectives by generating the data and comparing the data with the whatever the material resources available with me. Okay, so this is the first case study. It is about the metal hydride based hydrogen storage system, and with which I worked on it, and I have published good papers in the International Journal of Hydrogen Energies, which I have shown you earlier. Okay, now proceeding ahead with this same work, we have carried forwarded, and again we have defined some problem statements for this whatever the material systems are there. So again I'm moving ahead with the case 2. In line with that work whatever we have carried out earlier, we also come across that the major factor in the research of this metal reactor is nothing but the poor reaction kinetics. That is, whatever the reaction is happening between hydrogen and hydrides, there is a poor reaction kinetics are there, and because of which the rate of hydrogen stored into the reactor and rate of hydrogen released from the reactor are varied. Okay, so the problem statement what we have decided that after going through the, again literature, the metal hydrides are having poor reaction kinetics, which results into the storage capacity, which results into the lower storage capacity and large storage time. Because of the reaction kinetics poor, the capacity is also poor, and also time required for the storing. As I said, during the refilling of the petrol diesel, we can wait only for 5 to 10 minutes. But for the metal hydrides, if you are requiring more than that time, then one cannot opt this kind of systems. One cannot opt this kind of systems. Okay, so here we come to know that because of the poor reaction kinetics, the storage time required is higher, capacity that can be stored in the reactor that will be also lower. So hence there is need to enhance the heat transfer in the reactor. Okay, so what it deals, it is related to the heat transfer in the reactor during the chemical reaction which is happening. If you are going to work on that, then one can go with the detailed analysis or improvement in the performance of this storage time or storage capacities. So with this time, we come to know that there are different nanofluids which can be added to improve the properties like thermal conductivity of the material. So nanofluids are having the better thermal conductivity than the base fluid as water, because we are using normally water as a coolant in the hydride reactors to extract heat, and as well as also to take out the hydrogen. We are also supplying the hot water, but because of from hot water heat will be given to the reactor, and then from the reactor to the release of the hydrogen is there. So in this work, different nanofluids will be analyzed and their performance will be investigated numerically for heat and mass transfer enhancement in the metal reactor. So we have decided that can we opt the nanofluids in this base fluid so that there will be an improvement in the heat transfer in the reactors. If there is a heat transfer improvement, then the performance of metal hydride hydrogen storage reactor at the different design operating conditions can be analyzed, and we are going to check it whether there is a improvement in the performance or not. Okay, so see here, this kind of the nanofluids are there, particles are there. One can have the copper oxide, or you can have aluminum oxide like that. These are the different treatments with which Al2O3. Then we can have this method which can be used to convert this normal based fluid with the nanofluid based fluid. So there are different methods are there, Solgen methods are there, or other also methods are there with which one can add by some percentage of nanoparticles in the base fluid as a water, and one can get the improvement in the characteristics of the whatever the fluid is there. So major characteristics which we are getting is the improvement in the conductivity is there. Okay, and if the hypothesis says that if the conductivity is improved, automatically Q is equal to minus k dt by dx, or if you are going to have the conduction plus convection, that is the advection effect is there, then automatically you will get the improvement in the heat transfer. So that hypothesis we are going to have in mind, and with this nanoparticles and the preparation of the fluid, one can move ahead by using these nanoparticles in this metal hydrides. So I have defined the research question as, that is that to numerically investigate the effect of different nanofluids on the performance of metal hydrogen storage reactor at different design and operating conditions for heat and mass transfer enhancement. So what is the hypothesis behind this? That is, by using the nanofluids, it would be possible to enhance the heat transfer of metal hydrogen storage reactor. Okay. So this is the hypothesis in mind that nanofluids are having the good thermoconductivity, and if you are going to add these nanofluids by some percentage 0.123% or 1,235% in the base fluid, then there will be improvement in the conductivity of that fluid, and if that fluid is used as a heat transfer fluid in the metal hydride reactors, then definitely it will give the improvement in the performance of the reactor in terms of heat and mass transfer characteristics. So we have investigated it numerically. We have developed a model in the ANSYS plant. We have created the geometry, meshed it, then they have grid independence test for that. Then the validated that results with the experimental results of other authors which are published in the literatures. Then compare the results with the base fluid with the addition of the nanofluids Al2O3, copper oxide, or other three nanofluids we have selected, chosen. Then we have find out the different properties, density of the nanofluids, conductivity of the nanofluids, viscosity of the nanofluids, all these. And with that, systematically we proceed ahead towards the completion of the research. And with the end, we have got very good publications in the International Journal of Hydrogen Energy, and that research work is also completed. Okay, so this is the second case study we have taken into consideration, and where we have defined the research question through the exhaustive literature. We come to know what are the problems. Then from the problem, we have decided the problem statement, then the research question, research hypothesis, and based on that, objectives are there. So what are these numerical nanofluids are there? For that nanofluid, these are the objectives we have decided and completed also. That is to develop numerical model of metal hydride hydrogen storage reactor and validate it with published work. So here we have not done any experimental work. Okay, this is completely numerical work is there, and to validate our model, we have used the published research work. So some authors with the same data, same reactor, have done experimental work and published it. We have taken that permission and used that data, and we have validated our numerical model with that model. And whatever the, as earlier we have seen that the accuracy of the model, errors in the models, and then we have commented on that, interpreted the whatever the results we have obtained it. Okay. Secondly, to analyze, so this is the base model which is validated. Then we move ahead with our research, that is to analyze the effect of different nanofluids in heat transfer enhancement of metal hydride hydrogen storage reactor. Here we have run this model for the different nanofluids, 1, 2, 3, 4, like that, different nanofluids, and we have changed the design characteristics, operating characteristics of the reactor, and how data is to be generated for our research work. Then we have investigated this performance of this metal hydrogen storage reactor for different design and operating conditions with these different selected tools, as I mentioned. And at the end, we have generated correlations for these different nanofluids which are used in the hydrogen storage reactor. Because any other researcher would like to work on that, then he can directly see our correlations, and then with that values he can directly use the properties of that whatever the nanofluids which we have chosen for our research work, and get the different properties of that nanofluids, and how use of these properties for the different you can say the simulations to be run or experiments to be work for that metal reactors. Okay, so this is the second case study we have taken into account. Is it okay, madam? Audible?
Yes, sir. Yes, sir.
Okay. Thank you. Now, the next case study, just again, I would like to focus about now the current rise of batteries, electric vehicles and batteries of the electric vehicles are there. And as a mechanical engineer, we are having again wider scope in this thermal management of the battery systems are there. So we are also working on that. And here also we have taken one problem for the research work, and it is nothing but experimental investigation on thermal management of electric vehicle batteries using the composite materials. So many of you are working in the composite fields, and that composite materials can be now opted for the thermal management of the battery systems. So here I have shown the deliberately some of the photographs, picture snapshots of the different battery cells which are used in the electric vehicles or for the vehicles. So here in this left hand side picture you can see that the number of arrays of the battery packs are there. So all these are fitted in one stack, and you require to have a management of the temperature, that is thermal management of these EV pack batteries, because if the temperature of these battery packs are exceeding more than I may say 45 degrees Celsius to 60 degrees Celsius, then the performance of these battery cells is deteriorating with the time. And also during the charging or discharging with the different rates, 1C, 2C, 3C rates, the temperature attained in the battery cells are also different, and we require to maintain these temperatures between 25 to 35 degrees Celsius during charging or discharging. Then the life of the battery and the performance of the battery is well. So as per the literature, we come to know that the you require to maintain the temperature in that range, 25 to 35 degrees Celsius for the battery stacks. So people tried a lot with the different methods. Earlier we were having the air cooling methods, water cooling methods, with the water adding some additives, then have improvement in the performance and all this. Then people shifted towards the PCM, that is phase change material, and with the PCM paraffin as a material, they have used it. Then they have built up the different, I can say single cell. Then you can have battery stack with the 4 cells, 8 cells, 12 cells, like that. They have numerically investigated. Some of them have experimentally investigated it like that, and they have come up with the different results as a research outcomes. And everyone have mentioned with certain given conditions the maximum possible temperature attained by this cell with these materials in the range of so and so, so and so, like that. Okay, so in the second figure you can photograph, you can say it is a sample of pure paraffin is there. So this is the battery stack which is made up of the paraffin. Then this is the battery pack which is made up of the copper foam plus paraffins are there. This is the battery pack with the different materials, CCFCS, and second sample is also there with the CCFCS and paraffins are there. Okay, so this is the one of the author research work is there who used these different kinds of combinations of the battery stack and compared it with the pure PCMs. Okay, like that. So one can use the phase change material or have addition of some composites in that. Then you can get the CPCM, composite phase change material, CPCM, CPCM, composite phase change material. And one can nowadays use also the carbon nanotubes. One can also use the graphene, graphite oxide, like that. different composites are added in the PCM, and with which they are trying to check the what we can say the thermal management of the battery systems. Okay, so this is the background of this problem is there, and here we would like to have a research questions hypothesis for this. And I have come to know that this is my research problem, that I would like to improve the performance of the battery in terms of the temperature or thermal management. Okay, so what are the my research question is that what are the techniques adopted to improve the EV batteries life? Okay. Because the life of the batteries, as I mentioned, depends upon the most one of the parameter, that is the temperatures, which are raised during charging and discharging. So my question is, what are the techniques adopted to improve the EV batteries life? So I can have a hypothesis that the use of passive cooling or active cooling, you know it well. So improvement in the passive cooling of battery due to use of high thermal conductivity battery exterior made up of composite materials, one can improve the life of the battery by having the proper heat transfer, temperature management, by providing the high thermal conductivity materials which are put provided in the exterior of the battery cell or battery stack. So presently people are using suppose PCM material, water or the air as a coolant. Instead of that, if you are going to have any passive cooling method, and with in that if you are going to use the high thermal conductivity materials like composite materials, then it will be giving towards the improvement in the performance of the batteries. So it will second hypothesis that reduction in the maximum temperature. If you are going to use these passive techniques with high thermoconductive materials, then it is assumed that hypothesis says that there will be the reduction in the maximum temperature built up in the battery pack due to the enhanced cooling. So this will lead towards the reduction in the temperature which is attained in the batteries during the working. Then if the temperature is reduced, our enhancement in the cooling is there, automatically it will increase the life of the battery due to decrease or reduction in the temperature built up in the battery cells. Okay, so these are the hypotheses that improvement in the passive cooling, reduction in the maximum temperature or increase in the battery life, these are the because of the thermal management of the batteries are there. So if you do this, definitely your answer to the research question will be getting, that is these are the different techniques with which we can opt for the batteries, then it will improve the life of the batteries. So like this, we have made for the case study 3 the research questions and the hypothesis based on this research. So we worked on that, and also we got very good or fantastic results with this. We are also in the stage of publishing the work on this thermal management of battery system using the composite phase change materials. We have the experimental setup in our college with which we are going to have the charging and discharging of the battery cell. We are having some battery cycler with which we are charging the cell. We are using the 18650 cell, and we are using the composite phase change material as a graphene based. We have developed a casing with the 3D printing technology, and we have inserted the cell at the center, and around which we have poured the composite phase change material, mounted the different thermocouples and have a complete system for that, and with which we have gathered the data and compared this data with the without composite phase change material, with phase change material, and with bare cell, that is without any material are open to air, bare cell is there, and we got the very interesting results, and we are in the phase of publication. In fact, one paper get accepted for that, and we are moving ahead with the different publications also. Last case study just for the research questions, that what suppose you are going to have a use of the renewable energy technologies, and nowadays you know that lot many promotions are going on for the use of renewable energy technologies, and everyone as a mechanical engineer we know that there is a need to shift, to transfer, to move towards the renewable energy technologies, use of technologies. So someone wants to work on that, that is use of the renewable energy technologies, or promote the peoples to use for the renewable energy technologies. So then the what is question is for that. So what are the factors that influences the adoption of renewable energy technologies? That is my research question will be there. What factors that influences the adoption of renewable energy technologies? The hypothesis for this will be the higher level of environmental awareness that leads to increased adoption of renewable energy technologies. If you are going to create awareness about the environment, awareness about the resources, awareness about the impact of these non-renewable energy sources on the environment, then automatically the our resources available for the use of the renewable energy technologies, policies which are available for the renewable energy technologies, automatically it will lead towards the influence, it will lead towards the adoption of the renewable energy technology. So there are different factors which are going to influence, and one of that is that here decided that the environmental awareness that can be lead towards the adoption of renewable energy technologies. So as you know that, just I have taken the simple example of that. Nowadays, the government is also promoting the solar PV cells. That is the PM Saur Ghar or Mukt Bijli Yojana. Okay, or you can have the Kusum Yojana for the pumping water from the wells in the fields. So these are the some of the policies or technologies adopted by the government also in order to promote the different non renewable energy sources, and automatically awareness among the people will be created, and then definitely it will move towards the use of these technologies. Just it is added to get insight about it. So these are the case studies just are taken into account for the understanding of research design and planning. And one of the major factor that hurdle any researcher come across is defining the research question and hypothesis. Even though right now with me multiple students are working under me, and whenever we ask the question, even though while submitting your synopsis to the respective universities or colleges about your research work, then the first question people will ask that what is your research question. Before that they will ask what is your problem statement, what is your research question, and what is the hypothesis of your research. Okay, so many times we people are not well aware about this, how to define the research question of our problem, and what is the hypothesis of your work. Okay, so I hope that with these three to four different cases which I have handled in the last few years, I am able to clear you that how to frame the research question and how the hypothesis can be framed based on your work, and based on this question and hypothesis how the objectives of work can be decided. Is it clear?
Yes, sir. Yes, sir.
Okay, very good, thank you. Now with this case study we will move ahead with the planning stages. Now earlier to this I show you the matrix of research. Now this is the matrix of planning research. Okay, so now you are going to plan the research whatever you are designed. So again you have questions, sub questions, and then your decisions. Now you have research question, you have sub questions also on the research, and now you are getting some data from that, or you are gathering some information by grounding the theory of the whatever the problem you are having, and with that we have, or you are having some data with you, we are having some questions with you, we are having some questions with you, and with that you require to take some decisions at every stage of the research design, that where to stop, where to go in depth, where to enlarge the boundaries, where to expand the work, where to get narrow work, like that, whatever the decisions are there. In general, in broad sense, you require to take the decisions. So you have the planning matrix where you require to have questions, again have sub questions, and have decisions on that. Intermediately, frequently at every stage of research, when you are going to approach through the what are the framework you are designed for this research, you require to take the decisions. And during this decisions making ability, your supervisor, your subordinate, or your colleague who is superior to you, he is going to give help a lot while taking the decisions. The supervisor's role is coming over here, that whatever the findings you are having, where to limit, where to go in depth, where to go ahead, that kind of decisions are required in the planning of the research work. Okay, so making decisions is very important during the planning of the research. At every stage of the planned design, research design, you require to take some decisions. So there are four factors in making decisions that are shown over here. The first one decision is coherent decisions, that is not contradicting each other. So your results are straightforward, and these results are not contradicting. Means what? Suppose, as I mentioned earlier in the my whatever the design cases shown to you, that is addition of the nanofluids in the base fluid will improve the heat transfer by because of the improvement in the conductivity. So if I added it, I have tested the fuel, I found that improvement in the conductivity property. So it is a straightforward, non-contradictory result is there. Then I have used that fluid to my system. Then I have run that system. Experimental work is done, numerical work is done, and also I got some results from that, and that results are also showing the improvement in the heat transfer. So there is no any contradictory between the whatever the hypothesis I have made, whatever the results I have obtained, whatever the procedure I have used, whatever the framework I have designed, and process I have opted, and with that steps I have moved ahead and I got the results. So in that case, making decision is very simple. It is a coherent decisions. These decisions are not contradicting each other. So only people are going to say that try to take it in terms of the percentage change, because every one of you must know that during publication of the work, no single numerical values will be put that I have got 30 kilojoules of heat improvement or 100 kilojoules of heat improvement. Not like that. You need to write comparative improvement with the base, whatever the material or whatever the system you are going to have. So there is a, by the use of the nanofluid as a copper oxide, there is a 10% improvement in the heat transfer as compared to the base fluid water. Like the statements are expected for the research publications. And here we are talking in terms of the percentage change, and these results are coherent results. Okay. Secondly, that mutually supporting each other. That is again taking the same example. That is, I have used the copper oxide as a fluid, then I have used the aluminum oxide as a fluid, nanofluid, and like that, and then I have obtained the results for that. And then the results which are generated with each and every nanofluids are coherent, and they are supporting mutually each other, because the how the gradually change in the conductivity there, with that gradual change I am getting the change in the heat transfer and all this. So with this I am getting the mutually support to each of the statement, each of the results I am getting for that. Okay. So during that also you require to take the decisions. Then must be practicable when taken separately. Okay. Now I say that by addition of the nanofluid in the base fluid, I got the improvement in the conductivity. Okay. But my results are showing that the increment in the or change in the conductivity of that fluid is somewhat some 50 to 100 times more. So immediately I have some concerns on that value, because this value must be practicable. Okay. Otherwise, you can say that the whatever the value I have obtained for the conductivity of that material by addition of these is not a realistic value, is not practicable value, because you have the zone, you have the range of the values of the thermoconductivity of each and every material, and by addition of some 1%, 2%, there will be some, I may say that, incremental changes in the properties, not a drastic change in the property. If so, suppose, then you have to go in depth about that, how that value is coming, whether there is any mistake in the data reading, whether there is mistake in the process, whether there is mistake in the material which is chosen, or any mislead, whatever happened, like that. So you have to think, get the decisions on that. that it must be practicable when taken separately. Then it must be predictable when taken together. So prediction is nothing but one kind of the hypothesis based is there. Okay. So as I mentioned that if I add 1% of nanofluid in the base fluid, then I have the value which will be in the range, because 10 is the suppose base fluid value and 100 is the nanofluid value is there. Then if I adding 10% nanofluid in this base fluid, then the value will be increased only by 10 to 15%, not beyond that. So that is my prediction, because it is just addition of the one fluid in the second fluid, and there will be change in the value of the conductivity within the whatever band of that both fluids are there. So I can predict it. Okay, so it must be predictable when taken together, and with that I should take the decisions that whatever the results, whatever the data collected, obtained, or observed by the researcher is correct, is not correct, not verified, there is the error, like that decisions you required to take. And with respect to whatever the basic research designs, questions, sub questions are there, intermediately during the planning, you require to take the decisions. Okay. And so taking decisions or making decisions at every steps, this is also very important. Is it clear? So making decisions are having the four types: coherent decisions, supporting decisions, then the practicable decisions and predictable decisions. And if you take the decision timely, then your research will progress fastly, and you will get the very good planning and execution of the whatever the research questions are there. So here, as I mentioned, this part we have covered right now, that is the defining the problem. Okay, in the research planning stage, just because of PPT, just I would like to again showcase to you defining the problem, that is the clearly understood, then the formulate the research objectives, then we are going to have the literature review on that, and exhaustive literature review. If you do it, then you have to summarize the findings, that is nothing but research gap. With the research gap, as I told you, we are going to have the problem statement, and from the problem statement we are going to have research question, research hypothesis, objectives. Till this slide, whatever the part we have learned is covered. Okay, so many of you are well known with this, that to get the literature review in depth for the mechanical engineering, this is one of the best site, that is sciencedirect.com. Sciencedirect.com, this is the website where you can get, many of you are, might be having the subscription of this site. ASME also site is also there, where you can just put any single login to any single word, and then you can get the thousands of published works, and we can have filter over there, the papers published in the 2024, papers published in the engineering, papers published in the particular journal, and then you can tick the number of filters, and you will get the you can say filter the data related to your problem statement. I hope that many of you are well known with this sciencedirect.com, but many of you might not be having the subscription for this. You can take the help from the your friends or colleagues from the reputed opinion institutes where the subscription of this sciencedirect.com is there. Now the purpose behind showing this slide is that you have done the exhaustive literature, and you are moving towards the research design stage. Okay, research design stage by asking the research questions and the hypothesis on that. Here we have the relation between the literature review and the research design. So what is the relationship between these two? Okay, because unless and until you are not going through the literature review, you are not able to design the research and then plan the research. Okay, so literature review, whenever you go through it, whatever the problem you have defined, that is the broad sense problem initially. That is, suppose I say that I would like to work on the metal hydride reactors. It is a very broad sense, and in that I may say that it is related to heat transfer reaction kinetics, like that. So now I have started going through the literature for this. Then it will describe how the proposed research is related to the prior research in the statistics. That is, whatever my proposed research is there, if I go through the literature, it will going to give the relation between the prior research work done by the many researchers and my research. Then also it shows the originality and relevance of your problem. You will come to know that what are the different types of possibilities people have tried in the past in your research work, in your area, and how they have presented their work, how the originality of that work is there. It justifies your proposed methodology. It also tells you that how they have proceed ahead to complete their work. So whatever the methodology you are opting in your research design and whatever the methodology chosen by them, there will be justification between these two. It also demonstrates your preparedness to complete the research. When you go through the literature review, it is also going to demonstrate you your preparedness to complete the work. That is, you will get the guideline, you will get the, I may say that the mean path, that how these researchers are proceed ahead in our area, whatever the chosen by us. Okay, so there is a relation between the literature review and the research design is there. Unless and until you are going to not going to do the literature review, you cannot have a research design. Okay, earlier I also mentioned to you that if you are going to have the good literature review, that will provide you the description about the problem summary, then the critical evaluations that are there in your research problem that you want to investigate in details. Okay, so there is a relationship between the literature review and the research design is there. And this slide shows you that unless and until you have exhaustive literature review, you cannot have a research design. And one cannot say that for my topic there is no any literature, there is no any paper that I can cite. Okay, you have to move in, or you can move back in the border sense, not in the only T point sense. Okay, so you can give the border key search in the sciendiary.com, and then you can go through the different papers, and then you come to know that yes, there is these are some of the inclinations which are very close to my proposed work, and how the people have done the work in that areas. And with respect to that, you can also refine your methodology which is opted by you. You can also redesign the questions. You can also rewrite the hypothesis of your work before going towards the final research design and planning. This slide also I hope that just I have taken it because it is in line with whatever the research design is there. So to have an exhaustive literature review before the research design, you can use the different sources of literature, that is the primary source, secondary source, tertiary source. That is the different sources are there. Okay, so primary source means you can use the author's original work or research report and researcher that conducted the study. Okay, suppose any student working under my guidance, and immediately I got next student, then I can say that this work you can carry forward. So I have given the primary source of the literature to him, and through that he can go ahead with that. Secondly, that work cited by another authors or research that summarizes or reports findings that come from the primary sources. That is, you can have a review of the literatures. And the third one is that distillations or collections of the primary and secondary resources. That is the catalogs or different books or different, you can say the publishers where that work is related. And you can go through it and collect the data. So collection of data is very important in the literature use. So once we formulated this hypothesis, okay, so again come back. I am again recapping all the things. We have gone through the types of literature. Before that type of literature, I told you that you require to have a broad sense of the problem. From the broad sense, you are going to have the problem statement. Then you are going to have research questions. Then the hypothesis of the research. Okay, to the literature review. So here, point number 3, we have completely formulated the hypothesis. So we have developed the hypothesis, and we have defined the different variables with which we are going to conduct the research and all this. And we have chosen the research design. That is the what we are learning. Then what are the different methodologies we are going to use. So once you are designed the steps and plan it and trying to execute it, you have to use the methodologies. Then most important part is the data collection is there. So to develop a data collection plan, and as I think that yesterday this part is also covered, what are the different methods, and also I hope that one of the session is also there on the collection of data, different types of data. I have gone through the different session titles. So here you also require to collect the data in the research design. So sampling strategies, data collection, different methods, pilot testing, and this. Then once you collect the data, then implement data collection, and then you require to analyze the data. And analyzing the data, it may be qualitative analysis, quantitative analysis, like that steps are there. Okay, so I'm just would like to tell you that this part I would like to skip. That is the what are the different methods of data collection. Now, why it is required? That part I think that you all well known, or in the coming lecture you may get it. That is the so you required the what are the different key components of data collection? That is defining data collection methods, then the sampling techniques, data collection instruments, how you are going to collect it, and ensuring the data quality. As I mentioned earlier, if you are going to do work continuously and you are not looking at the values which you are getting from the data, then there is no use of the work. Immediately any data come to you, you have to work on that data, look at the data. As I mentioned that the heat transfer value with the addition of the nanofluids conductivity is improved or not, immediately you have to check that by addition of 1%, yes, there is some improvement in the K. Immediately when you work out, then the if you find the K Q heat transfer, yes, there is some improvement in this. How much improvement, that is the analysis part is there, but at least you have to check that the whatever data you are getting, that is of the good quality data. Okay, so this part I will not take the qualitative methods, the quantitative methods. So you can have different surveys, questionnaires, experiments. Then the probability of the sampling techniques, how you are going to use it, the random selection, stratified selection. You can have a cluster, as I said that Kolhapur country sections as a cluster. Then you can collect the data from that, or pollution MIDC sector, like that. You can have the clusters and you can have sampling of that. Then you can have the non-probability sampling also. You can take all data. You can take the particular data or any characteristics from that data, like that. You can collect the data by different methods. As I said, you can have a survey, you can have questionnaires, you can post the questionnaire through the different medias now. You can reach to different peoples, collect the data on this. You can conduct the interviews of the different peoples. You can record these, okay, with the audio, video, things like that. Nowadays, many people are working on this. You can say the drone technologies and analysis using the image analysis and all this. Okay, that part also one can take it. Okay, so for the crop conditions, as you know that in our areas, most of the times sugarcane is one of the crop is there, and one can have the analysis of the leaves of the crops at the different stages after 1 month, after 2 months, after 3 months, like that, and you can capture the image. One can give the input to that. You can take the help of the AI analysis, like that. Also, things are going on like that. Here also you can have the recording things. Okay, then the observation checklist, then the ensuring the data quality, that whatever the data you have collected, you have to ensure that it is quality data. Then the analysis of the data with the qualitative analysis, quantitative analysis. And with this stage, whatever the data you have analyzed, okay, you require to support your data or validate your data. This is very important, and that parts come in the report findings. That is, whatever the data which is collected by you, you require to first validate that data. Then you have to, what are the new findings you are having, interpret the data. You require to draw the conclusions and write the report on that. Okay, and then you are going to disseminate the results, present the findings where at the various publication house, or you can have the feedback on that, revisions on that, and all this. That the stages of the research planning processes are there. Okay, and as I mentioned that before going for this report writing, findings, and publication of this research work, you have to take the major concern about the ethical considerations. The nowadays more concern is given by the research society about the ethics. Okay, so whether you have taken the consent of the data which is copied from any literature, or you are going to use the anyone's figure as it is, or any data you have copied from that and using as it is. So it is asked clearly that whether you are taken consent or not. So inform consent. Then sometimes it happens that you are doing the research work with some sponsor agencies, any company or anything, any organization, and where there is a confidentiality of data is there. So that also you have to mention or clearly tell that this data is protected under the confidentiality so and so. At the initial stage, while writing the data, publishing the data, you have to tell clearly that there is a confidentiality of the data is there. Then you have to also avoid the bias. Okay, bias is should not be there. Implementing the measures to reduce the researchers and the participants bias, ensuring the objectivity in the data collection and analysis. That is, in earlier paper on the same work, same thing. If somebody else have published the data, you have used the same thing, same conditions, same, and you have generated the second data. So automatically there will be bias between these two datas are there. And if you are going to publish these datas, then there will be the bias between the two datas, and you need not require to have bias on that. You try to work on the data. You try to interpret the data, why this bias is there before publishing it. You have to interpret the data correctly. You have to support the statement with the fundamentals, with the principles, and then only you can publish the data or present the data with if any bias in the work is there. Now, once I think that once you are going to have the ethical considerations, your research design is there, planning is there, you have collected data, implemented data, and trying to validate the data, and now you are ready to publish the work. Then these are the some of the sites. Just I would like to highlight to you. That is, there are different sorry publishers where you can present the work. And before that, you may have a question in your mind that where I can publish my work. Okay, so how I can find a better journal where I can get the good publication. I can also get recognition of my publications, all this. So here are these are the some of the websites where you can have the finding the journals if you are going to have your title of the research work and abstract of the research work. So you can have this Elsewhere Journal Finder. I hope that most of you are you might be known for this. Then Journal Guide is also there. This website is there, journalguide.com. Then you can have IEEE publication recommender also, where publication-recommender.ieee.org.com is there. Okay. So if you click on this site, you will get the here. If you click on the site, you required to give some input data to this site. What data is required? You require to give the title and abstract. So this is one of the sample I have just shown. This is the title, and this is the abstract of my work is there. And you can have this. You can see here the journalfinder.elsewhere.com. This is the website. I have just opened it, and here you are getting enter your abstract. Okay, so by clicking over here, you can enter your abstract over here and find the journals. If the time permits, I may show you that how many journals you are getting for it. And once you click over here, the this website is going to show you the probability where you can upload your work for the publication. Also the statistics of the journal, that how much time required for the first decision, second decision, publications, how much probability of the acceptance rate, rejection rate, all these data you are able to get it with this journal finders. So you can have the data with you, abstract with you, and you can put over here, and one can get the different titles of the journals where you can upload the materials. Okay, so once you are going to get the journals, there are some basic fundamental requirements to upload the paper. You require to prepare the cover letter for this journal also. And many publishers are asking this kind of journal. So you can have this cover letter. So I just prepared to the editor, International Journal of Renewable Energy, subject submission of manuscript to in the Journal of Renewable Energy. And I can say that, dear sir, please find the Please find attached the manuscript titled authored by authors for possible publication in this journal. Hoping to hear from soon, and like this. So this is the one of the, not like this, but this is one of the letter I have prepared, and just you can. So they are asking while uploading the paper, they are asking the cover letters also. They are asking cover letter. Then they are also asking the list of the reviewers. Many journals are asking the list of the reviewers. You also required to prepare the list of the reviewers. Now the question will come to in your mind from where I can give the list. One thing that every researcher have to keep in mind that whenever you are going to upload the paper to any journal which is funded by you from the journal finder or else, that journals must be, papers from that journal must be cited in your paper. That is not mandatory, but it is inclination. That is, you are saying that your research work is related to your journal where you would like to publish, and you are not at all citing any paper from that journal, then there is a mismatch. Then there is a mismatch. Okay, so you require to get the details about the different literature, different reviewers names. So you can take the reviewers titles from the papers which you have uploaded, or you have used, or you have cited. Okay, the papers which you have cited, from that you can take the corresponding author, star is there, their details are there, title is there, university is there, email ID is there. So this data you required for the reviewers. So name of the reviewer, where this affiliation, address of the university or college, and email ID. And minimum 3 reviewers you required to give for the papers. Earlier days they were not asking, but nowadays every journal is mostly asking this kind of details. And also it doesn't mean that you are given this list means only the paper will be sent for the review to these authors. Not at all like that. They are increasing their database, because while uploading this they are going to ask for everyone your research areas, then broader areas, sub areas, like that. And whenever this key results, because in the paper you are also writing keywords, and if the keywords are matching with that words, then and then only that will be filtered out automatically in the software. Then nowadays you require to give also highlights while submitting the paper. Highlight of your work. Abstract is different, title is required to be given, abstract is required to be given, keywords is required to be given. Other than this, you require to give also highlights. Minimum 3 to 4 bullets you require to add in the highlights. So here, these are the some of the highlights just mentioned over here from my work. That is, a mathematical model of metadata reactor for hydrogen storage is presented. Then heat transfer is seen to be major contributor for entropy generation. Then results show the need of trade-off between cycle time and entropy generated. So that if you see, if you are not having subscription of sciencedirect.com, and if you enter any keywords and you are getting the paper titles, then you are able to get the title, abstract, and highlights. This data will be displayed free of cost. So earlier days these highlights were not there, but now every paper they are asking the highlights, and this much data they are going to publish, or they are going to give free of cost to the research societies. So you require to again write the highlights of your research work while putting the draft of the paper in the research. And then you have to prepare the manuscripts as per the author's guideline given as per the every journal. As I said that you require to have figures to be cited, tables to be cited. Then manuscript should be well planned, spell checked, grammar checked. Okay. Then papers which are cited, all papers in the references must be cited in the papers. Okay. All these things you require to take into account while writing the manuscripts and prepare the manuscript fully. Now, most important thing in the research design is the data validation is there. So where we can validate your data, you can validate your data with the experimental data of your own which you have conducted. You can validate your data with the experimental data which is published earlier, or you can validate your data with the earlier researchers whose work you have carried forward. Okay, so data validation is very important, and whatever the published work is there, from that work you require to capture the data, and by capturing the data you have to compare the data. So once you capture the data, you will get the xy coordinates of that plot, and then you can have comparison of that plot. So here one of the software freely available, that is plot digitizer is there. If you use this plot digitizer software, where you can put the PDF file of that software, and you can fix the XY coordinates. Then you can get the data of that. So here, this is suppose the plot is there, and for this plot, I would like to get, suppose these are the different curves, 10 bar, 20 bar, 30 bar, and my work is also related to this work, and I want to validate my numerical model with this experimental model. Then I can capture this data of x-axis, y-axis coordinate by using the plot digitizers. It's very simple. If time permits, I may show you. So this is the data validation, and you can use the plot digitizer software tool to capture the data. And lastly, the point is timeline for the different activities. You have to make this chart. You have to categorize different activities of your research design. You have to allot the time for each and every activity. So Gantt chart type activities are there, and you can have a timeline for that. So this is the about the project timelines are there. Timelines are nothing but it is creating well structured timeline, and which is essential to ensure that research project progresses smoothly and meets its objectives on the scheduled time. If you are going to have the timeline, then it will give the clear idea about you, your research work, about your research design and plan. And with the time, if you proceed with the plan, if you proceed ahead, you will be able to march the objectives and complete your work. So you can have the work to be planned as a week 1, week 2, and what activity you would like to conduct. So like that, detailed planning can be given in your research design. Okay. So here you can have the project planning and design. You can have research design and methodology in the fifth, week 7 or month 3, 4. You can have data collection in the month 5 and 6. We can have data analysis and interpretation in the month 7 and 8. You can have report writing and review in the month 9 and 10, like that. Okay. So here you can see every week and activities are described, and what are the milestones that I would like to achieve that are given. And this is what the micro planning of the research design is there. You can have planning with the week wise, month wise, year wise, and you can have this complete research design and planning to execute it, your research work, and complete it within the time period. Okay. So decimation of the results. Lastly, the what are the different challenges and solutions while moving ahead with the research design and planning. People come across with the different challenges, and you require to get some solutions from that. So what challenges you are going to, that is first challenge we come across, that is defining the clear research problem. Many times, as I mentioned, our problem is not well defined, and because of which we are moving here and there, or we are moving with no base. Just we are going through the literature, and we are not able to get the clear problem statement. So here, challenge is first that to define a clear research problem. So we can how to get it, conduct a preliminary research, consult with the different experts, or use the iterative refinement. You can work on the objectives and have repetition, iterations 1, 2, 3, 4, 5, like that, and then you will get the final shape to your research problems. So it is ultimately because of the different research work, or you can say the consult with the different experts, that can be eliminated. That then the limited access to the data. Sometimes what happens, you are not getting the very good access to the data. Then you can get the solution by establish the partnership, use open data sources, negotiate with the different accesses are there. Okay. Then the ensuring the participant engagement.
So you require some help, or you can have, I can say that the different participations. Then you can have incentive participation. Then simply
Simplify participation or communicate benefits, like that. So you can have interaction with the peoples, and you can overcome that engagement of the different participants in your research work. Quality of the data and integrity of the data, that is also problem. What are the data which is received by you, is the quality or integrated or not. Then different constraints while collecting the data resources. Okay, so you have to prioritize this task. Then you can have additional fund to get this overcome these constraints. you can optimize this, what are the resources are there, like that. And lastly, the ethical considerations. So develop the ethical protocols, obtain the ethics approvals, and maintain the transparent communications. Like that. So what these are the different challenges people are coming across while have a research design and planning. And as I mentioned earlier, also that defining the research problem is very big issue to the researcher, and getting the different instruments to collect the data, availability of the different resources, utility of the different resources available for your research work within the given constraints. That are the different challenges, and as I mentioned that these are the different steps to get the solution for these different challenges. So last point is that suppose you have done the research design planning, you have worked out, carried out work, have good publications, and you are submitting your work to the university to get the title of the award of the degree. The people are going to ask you what is the contribution of your thesis to the society. This is very big question that will be asked by every external to the candidate. आपने क्या किया? Okay. So what is your contribution to the society? So you need to write down the contribution of your work in the slides. So here my work, that is a methodology to estimate entropy generation useful for optimal design and analysis of wide variety of metallites is developed. Then methodology to design hydride reactors for large scale hydrogen is developed. And development of methodology and models for capturing biohydrogen at low pressure temperatures is developed. Then development of techno-economic framework for evaluation of metal hydride-based pumps suitable for variety of heat resources. That is these are the my new inventions which have contributed to the society. One can use these new inventions and go ahead with this data or research findings for the further findings. So like that, these points are there. So thank you for this. I hope that I try to cover it mainly the what are the content which is given to me. Any questions, madam, please?
Yes, sir. Is there any questions from audience? Please ask.
Actually, I would like to show you the plot digitizers, how to collect data and all this. But if the time permits, then so here. Yes, any questions, please?
Is there any questions?
Madam, the lecture was recorded, or
Yes, sir. Yes, sir. Lecture recording.
so that can you provide the link?
Yes, sir. I will provide you. Is there any questions from audience?
So I hope that I have tried to cover the majority of data which is related to the research design and hypothesis of research, and I hope that it is helpful to each one of you. Also, I thanks to the organizers for giving me opportunity to conduct this session. I hope that this is helpful to all of you. If
Yes,
any queries are there, you can contact on the email. Madam, you can share my email or
yes, sir.
contact number also.
Yes, sir.
We
Yes,
are
sir.
here at RIT, very close to you. No
Yes.
problem.
Thank you, sir, for explaining the research design with different case studies that you have explained us with us. It gives us clear ideas about the how to frame research questions and hypotheses, how to work with the objectives, and you have explained also the planning matrix for research planning means how to decision making, how it important in research design, and At the last stage, you have explained the uh, for giving the information about the finding the journal on Journal Finder, and also giving the information about the other parts, that is the how to make cover letters and all the means small things which are important in the research planning. So you have all covered in this session. So thank you very much, and I express vote of thanks on behalf of PVPIT Budgaon to our expert, Dr. S.D. Patil sir, who spared his time from his busiest schedule with us. So, thank you very much, sir. Your lecture will definitely help us in our research work. Thank you. I request all participants.
Thank you, madam.
Okay, sir. If you have any questions, then put on chat box or on WhatsApp group, and Vani sir will help. Vani sir will share with you a feedback link. Please give the feedback also. Thank you.
So can I leave, madam?
Yes, sir. Yes, sir.
Okay,
Thank you,
thank you.
sir. Thank you very much, sir.